Hey there, and welcome to this explainer on the Gemma 4 open model family. Go ahead and grab a seat. Today, I really want to walk you through the architecture of Gemma 4. Whether you're a junior developer looking to seriously level up your skills, or you're already architecting large-scale systems alongside me, you've got to know how to deploy open weights. They're absolutely critical right now, and we're going to cover exactly how powerful agentic AI can now run literally everywhere, from massive enterprise clouds all the way down to tiny edge-deployed robots. Let's get into it. 256,000. That is our context window now for the largest models. Let that sink in for a second. When you're building out your applications, having this massive context window paired with native function calling means your model can ingest entire massive code bases without losing the thread. Honestly, gone are the days of hacking together workarounds, chunking text into tiny pieces, and just praying the model remembers the beginning of your script. It can actually reason through massive documents in one single go. It's a total game changer for the agentic era.
So here is our roadmap for today. We'll start with the Gemma 4 philosophy, move into deploying in the cloud, then dive into local power and parallel agents, AI in your pocket, robotics and IoT integration, and finally, building the Gemmaverse. We are going on a zooming in journey today, starting way up at the massive cloud scale and working our way all the way down to microscopic offline devices.
All right, part 1, the Gemma 4 philosophy. Run everywhere, highly efficient. The core philosophy driving this release is delivering the absolute maximum amount of intelligence per watt, completely customizable, and, importantly, under a highly permissive Apache 2.0 license. As an engineer, you want control over your deployments, right? Moving away from custom licenses to Apache 2.0 gives you full production control. It ensures you have the flexibility to build real commercial applications without getting bogged down by restrictive red tape. Now notice how these 4 distinct model sizes essentially give you a precise toolkit tailored perfectly to any hardware constraints you might face. You don't always need a sledgehammer to crack a nut, you know? If you're building for IoT, you grab the 2 billion parameter model. For mobile apps, the 4B. Now, if you need a local assistant on your laptop with super low latency, the 26B mixture of experts is incredible, meaning it only activates the specific parts of the neural network it actually needs at that exact moment. Highly efficient. And for maximum reasoning power or fine-tuning, the 31B dense model is your heavyweight champion.
Moving on to part 2, deploying in the cloud and scaling up with Google Cloud. Serving models at scale requires you to really understand your infrastructure options, and developers basically have 3 distinct paths here based on exactly what they need to build.
Choosing the right cloud serving environment basically comes down to exactly how much control you need versus how much server management you want to entirely avoid. If you want easy one-click deployment or a simple pay-per-token API access, you use Gemini Enterprise. But let's say you're like me and you want to tinker with every single infrastructure knob until it breaks. Well, that's when you spin up Google Kubernetes Engine, or GKE, for full VM access. However, if you want a solution that automatically scales to 0 when traffic drops, which saves a ton of money, Cloud Run is your best friend. Literally 2 lines of code and your endpoint is live. Okay, let me break down this architecture for you, because this is the good stuff. We're looking at building agentic workflows using the Agent Development Kit, or ADK, to autonomously solve complex revenue problems for a Citi Bikes database. Instead of relying purely on cloud compute, you run the ADK framework right on your local machine, tied to a localized 31B Gemma model. Then you configure a BigQuery MCP server to securely bridge into your enterprise cloud database. So you just ask your local agent, hey, help me optimize revenue. The model analyzes the schema, writes SQL queries to find bike locations, and if it makes a syntax error, and let's be honest, we've all bungled an SQL join before, it reads the error and fixes its own SQL code automatically, no human intervention. This is exactly how you masterfully integrate local models with cloud-based BigQuery services. All right, part 3, local, power, and parallel agents running off the grid. We're going to leave the cloud behind for a minute and look at how you can achieve incredible throughput directly on your own local machines. When you're building experiences like the AI Venture retro game, which perfectly demonstrates what we call vibe coding, where the model dynamically writes HTML, CSS, and JavaScript on the fly, you can effortlessly toggle between a cloud API endpoint and a fully local run using transformers.js or Alama. The best part? A local run costs absolutely nothing in ongoing server fees. When you're prototyping and making hundreds of API calls a minute, this completely saves your engineering budget from skyrocketing. You just bypass the cloud completely. It is absolutely fascinating to see a single laptop orchestrating a little offline army of 15 parallel agents, concurrently writing code in Rust, Python, and JavaScript without any internet connection at all. Listen up, because here is your step-by-step guide for setting up this local development environment.
First, you download the Gemma 426B instruction-tuned model. Second, you fire up a local service, something like Llama CPP or Olama. And third, you point your application to the OpenAI-compatible endpoint running on your local host, typically port 8080. By pointing your agent harness at this local port, you can spawn multiple parallel agents that run purely on your machine's hardware. Zero Wi-Fi required. Moving to part 4, AI in your pocket, mobile device capabilities. Now we shrink the compute footprint even further down to the device that is quite literally always with you, your mobile phone. Thanks to LiteRT and AI Core, models like the 2B and 4B are heavily optimized to run directly on mobile hardware. Now, for app developers, Firebase AI logic beautifully solves hardware limitations by transparently routing queries locally first and instantly falling back to the cloud if the phone lacks memory. As an architect, handling device fragmentation is a total nightmare. Some flagship phones can run the model locally, older phones simply can't. By implementing Firebase AI logic, you create this seamless hybrid fallback. The user asks a question, if their device can handle it, it processes locally with zero latency. If not, it routes to your cloud server automatically. The user never even notices a difference. This offline, multimodal capability powers absolutely life-changing accessibility tools. Take, for instance, a Gemma running agent processing camera feeds locally to safely guide visually impaired runners. Because it processes visual and audio data entirely on device, it provides ultra-low latency audio cues, like warning a runner about an upcoming turn or a sudden obstacle, without relying on a spotty cell signal. This is a profound example of how Edge AI isn't just some fun gimmick for developers. It's a vital, reliable tool that actually improves human lives. Next up, Part 5, Robotics and IoT Integration at the Edge of the Network. This is where physical robotics and tiny IoT boards take full advantage of that highly efficient 2 billion parameter model we talked about earlier. From a desktop robot analyzing a chessboard, to tiny 3D printed ducks processing audio on a Raspberry Pi, the physical implementations of this lightweight model are just mind-blowing. The Ricci mini robot uses Gemma to natively identify pieces and respond to voice prompts. The open-source Duck Gemma project runs the 2B model on a Raspberry Pi 5, so robotic ducks can have an actual personality. And at the extreme edge, we are seeing models running on Coral boards. These feature a low-power machine learning processing unit, or MPU, capable of 1 trillion operations per second, or TOPS. That makes them absolutely perfect for ultra-low-power wearables. Finally, Part 6, Building the Gemmaverse and Community Customization. With over 100,000 community variants already downloaded millions of times, the true, lasting power of OpenWeights lies in customization. You aren't just limited to the base model we provide out of the box. As an engineer, you'll quickly learn that base models are great, but fine-tuning is where the real magic happens. Honestly, it's exactly like mentoring a junior dev. You feed the model specific examples, so it adopts the exact voice or the specific skills your enterprise actually needs. You might find a base model is way too verbose. Well, by fine-tuning it with just a few hundred examples of concise, direct responses, you permanently alter its fundamental behavior. It's how you take a generalized tool and make it an absolute expert in your specific domain. And these brilliant global developers aren't just making toys, they are researching real cancer treatments and breaking down massive language barriers to democratize access to AI. MedGemma is tailored specifically for healthcare and X-ray analysis. Cell2 to Sentence is actually helping researchers find new cancer treatments, and groups like Crane AI Labs and CEIA are fine-tuning the models to master Swahili and Portuguese, bringing advanced language processing to massive populations that were previously entirely underserved. Taking the time to build for your specific community can literally change the world. So with all these incredibly flexible tools available, from massive cloud arrays down to tiny offline wearables, what incredible application will you build next? Think about the architecture we discussed today. Think about how you can powerfully merge local processing with BigQuery databases using the Agent Development Kit. Think about how you can set up parallel offline agents directly on your own laptop, and how you can seamlessly route traffic between the edge and the cloud. The tools are completely open, Apache 2.0 licensed, and waiting for you to use them. The only bottleneck left isn't the compute, and it sure isn't the cloud. It's your imagination. So, what problem are you going to solve today?